Hello, this video is going to be on using partial products and the standard algorithm to solve 4 by 1 digit numbers. So I'm going to start by doing the partial products with a couple examples and then moving into the standard algorithm. But just like we did with the 3 by 1 digit numbers, it's going to be the same process for 4 by 1 digit. So if we started with 1,422 times 3, and I wanted to just use partial products, I'm going to set it up the same way that I did for the 3 by 1, so it looks similar to the standard algorithm, but then I'll break down each part that way. So what I mean by that is I'm going to rewrite this vertically. And then go over each of the parts through this problem. All right, if I start in the ones place like I do with everything else, I need to multiply 3 times 2, and I know that is 6. Next, I need to go to the tens place and multiply 20 times 3. If I think of that as just 2 times 3 first, I know that 2 times 3 is 6, but because it's in the tens place, I need to add a 0 to my first answer. So remember, 2 times 3 is 6, but because it's in the tens place, I need to add a 0 in my answer. So that is actually 60. Next, I'm going to move into the hundreds place. So I'm going to multiply 4 times 3. So what that looks like is, or 400 times 3, so I could start with 4 times 3, and I know that that is 12. But because I'm in the hundreds place, my answer is going to be 1200. And then last but not least, I need to go to the thousands place. So I need to multiply 1 times 3. But because it's in the thousands place, my answer is actually 3,000. Now that I have each of the parts, I can add those up. Starting in the ones place, I have 0, or 6, plus nothing is still 6. Moving to the tens place, 6 plus nothing again is still 6. Hundreds place, 2 plus nothing is still 2. And then the thousands place, I have 1 plus 3, which is 4. Oops. So 1,422 times 3 equals 4,266. If I went back and showed you where each of these partial products came from, starting in the ones place, I got 6 by multiplying 2 times 3. That was my first step. I got 60 by multiplying 20 times 3. I got 1,200 by multiplying 400 times 3. And I got 3,000 by multiplying 1,000 times 3. So if it's helpful, you can write out the equations on the side to show where each of these pieces came from. You can keep track by just doing what I did the first time. But this is using the partial product strategy. This will really get you set up for the standard algorithm when we get into that. But for now, this is showing where each of those pieces are from. So I'm going to show one more example of using partial products, and then we will do the standard algorithm after this. All right, so let's do 2033 times 7. Again, I'm going to set this up so it looks like the standard algorithm. So I'm going to change this into being written vertically. (2033 times 7). I'm going to start in the ones place as per usual. So I'm going to start by multiplying 3 times 7. I know that 3 times 7 is 21. So I'm just going to keep track of that right there. Again, how I got 21 was that I multiplied 3 times 7. I don't need that. Next, I need to multiply the tens place, so I need to take 30 times 7. Again, I can look at that as just 3 times 7, which I did just previous. So I know 3 times 7 is 21, but because we're in the tens place, I need to add that 0 to my answer. So that makes it 210. Again, I just took 30 and multiplied it by 7 to get that answer. Next, I'm going to multiply the hundreds place. Anything times 0 is still 0. So I actually don't have to keep track and write down 0. There's just nothing for me to multiply there, so I'm going to move on. Last but not least, we need to multiply the thousands place. So 2,000 times 7. There we go. 2,000 times 7, I can think of that as 2 times 7, which is 14. But because I'm in the thousands place, I need to add those 3 zeros. So I have 14,000. Again, I did that by multiplying 2,000 times 7. All right, now that I have each of my pieces here, my partial products, all I need to do is add those together to get my answer. I'm going to erase these expressions over here just so I don't get confused when I'm adding. But if you want to go back and rewatch this video just to see where these numbers came from, feel free to do that. All right, starting in the ones place, 1 plus nothing is still 1. 2 plus 1 is 3, plus nothing is 3. 2 plus nothing is 2. Nothing plus 4 is 4. Nothing plus 1 is 1. So 2,033 times 7 is equal to 14,231. Right, next I'm going to show you the standard algorithm, and that's very connected to the partial products. So let's get going. All right, if I wanted to solve 3,621 times 5. I wanted to solve that using the standard algorithm. I'm going to rewrite it. Vertically like this. Again, I'm writing it big because I'm going to show you each of the steps. First and foremost, we are going to start in the ones place. So what I'm going to do is multiply 5 times 1. That is equal to 5. Next, I'm going to multiply 5 times 20. Remember, when we do the standard algorithm, you can think of these as single digits, just as long as you know that these are different place values, obviously. So if I think of this as 5 times 2, I know that 5 times 2 is 10. The 0 stays here, and the 1 goes above the hundreds place. So I know that I said 5 times 2 is 10, but if we remember that this is actually 5 times 20, 5 times 20 equals 100. So I can imagine that there's a 0 in the ones place, there's going to be another 0 in the tens place, and then that 1 gets carried to the hundreds place. Again, when you are doing the standard algorithm, you could think of that as 5 times 2, which is 10, but I wanted to make that connection just so you see that the 1 is actually in the hundreds place, this 0 is in the tens place, and we can imagine another 0 in the ones place. If this is confusing, you don't have to do that. You could just think of it as numbers that you're multiplying, carrying it over. You will get into a rhythm. But as we're learning this and getting more fluent, it's really nice to pay attention to where everything connects, where the place values are, and all that good stuff. Okay, next we're going to multiply by the hundreds place. So I need to multiply 5 times 6. I have to do that step before I even think about this 1 that I borrowed over here, or donated. So if I think of this as 5 times 6, I know that 5 times 6 is 30. Next, I need to add that 1 to my 30 to get 31. The 1 stays in the hundreds place, and then the 3 gets carried over to the thousands place. Just to show you what that looks like, remember 5 times 6 is actually 5 times 600. So if I think of that as 5 times 6, I know it's 30. But because it's multiplied by the hundreds place, I need to add 2 more zeros. So 5 times 600 is actually 3,000. I just added this 100 from when we multiplied 5 times 20. So I'm showing you that it actually looks like this. So I just did 5 times 600, which was 3,000, but I can't forget this 100 from when we just multiplied. So if I add this up together, 5 times 600 plus another 100 is actually 3,100. So again, that's where that 1 comes from. It's in the hundreds place, and then the 3 gets to join the thousands place. Just to reiterate, if this is confusing and you just want to use the numbers, go back and listen to just explaining how each part is multiplied. That's totally fine. We just need to make this connection. That way we are on the same page with the place value. Okay, last we are going to multiply by the thousands place. I need to do this step before I even worry about the 3 up here. So 5 times 3, I could think of that. 5 times 3,000, I could think of that as 5 times 3. I know 5 times 3 is 15, plus 3 more is 18. So it becomes 18,105. If I wanted to show the connection, this is actually 5 times 3,000. So 5 times 3,000 is 15,000. 5 times 3 is 15, but because it's in the thousands place, we have to add the 3 zeros. And then I'm adding that 300 from the previous problem. To get my answer of 15,300. Oh, I'm so sorry. That didn't make any sense. I'm adding 3,000, not 300. So again, going through thousands place, 5 plus 3 is 8. 10,000 is 10,000 still. So that's where that 18,000 came from. We started by multiplying the thousands place and then adding that extra 3,000 from the previous answer. I'm going to show one more example, and then we are going to move on to something else. All right, I am going to do 4,207 times 9. And I'm going to show this using the standard algorithm. So I'm going to rewrite it vertically. I'm just going to show this straight through. I'm not going to take the time to write the partial products over there. If that is your preferred method, you could go back and rewatch some of these videos, or you can go back to the area model. Again, it's up to you what you are comfortable with and what you can do consistently. That is what we want you to be doing. Okay, I'm going to start in the ones place. So I'm going to multiply 9 times 7. I know that 9 times 7 is 63. The 3 stays in the ones place, and the 6 joins the tens place. Next, I'm going to multiply the tens place. Remember, I need to do this first step before I even think about the 6. So I know that 9 times 0 is nothing. It's still 0. Then I can add the 6 later. So 9 times 0 is 0, plus 6 more is still 6. Next, I'm going to multiply the hundreds place. So I can think of this as 9 times 2, which is 18. So the 8 stays here. Sorry, I keep erasing my numbers. 9 times 2 is 18. The 8 stays down here, and then the 1 is carried up here. Follow me. All right, last but not least, I need to multiply the thousands place. So 9 times 4. Remember, I need to do that operation first before I think about the 1. 9 times 4 is 36, plus 1 more is 37. So 4,207 times 9 is 37,863. Please look for the assignment on Canvas after you watch this video. We are going to be looking at 2 by 2 digit numbers using the area model and partial products in the next video. So stay tuned for that.